Hello, welcome to week 3 of Algebra 1 SOL Prep. This week we're going to be studying functions. Please follow along with your notes as we do these examples. Your notes show lots of information, but I want to highlight this graph part about finding the domain and range of a graph. When I say draw a box around the graph and do not draw a side for the box if there is no end to that graph, what that paper means is that if you look at this squiggly graph here, on the left hand side there is an end right there, but on the right hand side, if you see, there's an arrow that keeps going forever, so there is no end. So what that means is that when you're going to draw a box trying to contain this graph, that box is going to look like this, where there is no side on this end of the box, only a top, a left hand side, and a right hand side. When I say to look for the part of the y-axis inside the box, it is this side, this part of the y-axis contained inside of the box. So that is from -1 right here all the way to +2. That's what's shown here. And when I say the part of the x-axis inside the box, that means this part right here, where there is a beginning on the left hand side at -4, but when you extend towards the right there is no end here. The box does not stop here, so it keeps going forever, which is why the domain would be from -4 all the way to infinity. In other words, all of the numbers greater than -4. Let's move on to some examples. Here they're asking us to identify which relations below are a function. If you look at the boxes on your notes, it says that a relation is a function if in pairs of x and y, whenever the x repeats, the y repeats with it. But if only the y repeats, keep in mind that that means nothing. So following that information, let's try to identify which relations below are functions. Let's try this first set right here. We're going to be looking for the x's to see if they repeat, and I can see that this 25 here repeats again over here. So I would have to check to see if the y's also repeat, and they don't. One of them 7, the other one should also be 7, but instead it's a 1, so this is not a function. Looking at the next set of coordinate pairs, 13, 15, 17, and 18, the x's do not repeat, so I can immediately say this is the function, do not need to look any further. In the next set of coordinate points, I can see that the y's repeat y here. There's a 1 and another 1. But remember, if only the y repeats, that means nothing. So we can ignore the fact that the y's repeat and just focus on the x's. They do not repeat. So I can call this set of coordinate points a function. Let's look at the table of values below. Keep in mind that a table of values is really just another way to represent coordinate points. They're just written sideways. For example, this is the coordinate point 12, 19. So again, we're looking for x's that repeat, and I can see that this 12 repeats again over here. So I need to look at the y values to see if they also repeat, and they do. They both are 19. So I can also call this table of values a function. When we look at the mappings that we have here, let's look at the first one on the left. What this means is that this -7 is paired to follow the arrow together with the 2. This 3 is paired with follow the arrow of 5. This 0 is paired with follow its arrow of 4, so on and so forth. So they are just different ways to represent coordinate points. And the way to spot an x that repeats would be an x value. These are the input, the x. Any x value that has more than one arrow coming out of it, that would be an x value that repeats. I do not see any x value here that has more than one arrow coming out of it, so I can call this a function. When we look at the next mapping, right here, the 2 goes with the 3, the 1 goes with the 9. The -5 is paired with the 3, but then also with the -3. So that would mean one x repeating with 2 different y's. We cannot have that in a function, so this is not a function. Let's look at now the graphs. Let's look up here at this graph. The information on our notes says that in graphs, you should be able to slide a vertical line and up and line down from left to right or right to left, doesn't matter, over the graph, and it should touch only a single point on the graph at a time. So if I take this vertical line and I move it over this graph, if you see, it's touching only one spot on the graph at a time. Keep in mind that the graph is the squiggly line. The other lines are the axes. I'm only checking for the graph. So I can call the graph a function because the vertical line will only touch one location at a time. Let's look at the next graph. If I take this vertical line and I slide it from left to right, I can see that, for example, at this location, the graph is touching that vertical line at two spots, one here and one here. It should only be one spot at a time, so I cannot call this a function. Now, let's slide our vertical line over the next graph. Moving from left to right, here it's touching only one dot, good, only one dot. But when I move here, my vertical line is touching more than one part of the graph at a time. And keep in mind that in this specific location, the graph is just the dots. So I'm going to have to say that this also is not a function because it's touching more than one part of the graph at a time. Moving on to the next example. Here they're asking us to state the domain and range of each function. If we look at your notes, the notes reminds you that the domain is all of the x values included in the relation, and the range is all of the y values. So if we look at this set of coordinate points, all of the x values would be your domain. All of the y values written down in a list would be your range, and it would look something like this. Domain is all of the x values, range is all of the y values in their separate lists. Let's look now at this table of values. The domain would be all of the x values written in a list, and the range would be all of the y values. So that would look like this. Domain is the list of all the x's, range is the list of all the y's. You can do the same thing with this mapping diagram. The domain would be all of your x values. Remember that the x is the input, so this would be the x. And your range would be all of the y values, your output. That would look something like this. List of the x values, list of the y values. Remember that when you are looking at a graph to find its domain and range, we follow the same method that I showed you at the beginning of this video, a box containing every part of the graph that can be contained and an empty side of the box where you cannot contain it. So for this graph right here, you can see that you can contain the bottom of it. There would be a bottom to the box, but when I try to close up the sides, I realize that the arms, these sides of the graph, are going to keep going up and out forever. These are going to keep going up and out forever. So there really is no left side, no top, and no right side to this box, only a bottom. That would mean if there are no sides, that the part of the x-axis included in the box would really keep going forever. There is no ends to the side of the box. So the domain would be all real numbers. The range does have a limit. The range would have a bottom limit right here, but then it would keep going up forever. So it would be all of the numbers greater than this value right here of -2. Which is why your domain would be all real numbers, because there is no limit to the part of the x-axis that would be inside the box, but the range would have a limit at the bottom. When you're trying to do the domain and range of a graph that is just points, you will have to find the coordinate values of each one of these points. for the x values, you can see the x locations of each one of the points right here. And those values would be your domain, like this: -4, -2, 0, 2, and 5. And then your range values will be following the points to where they would hit on the y-axis right here. Follow it right here. These values would be your range right here: -2, 1, 2, and 4. Next problem. They're asking us to state the x and y intercepts of the function below. Your notes remind you that the x-intercept is the point where the graph crosses the x-axis. So on this graph, this is the x-axis. The point where it crosses the x-axis is right here. So the x-intercept would be the value of -1. And then the y-intercept is the point where the graph crosses the y-axis right here. So your y-intercept would be the value of +3. Let's look at the next problem. F of x is equal to 3x plus 3, and we need to find the x and y intercepts. If you look at your notes, it reminds you that the x-intercept is the point where the y value is 0. So let's do the x-intercept first. And we rewrite our function here. And we remind ourselves that this symbol f of x really means the y. So you can rewrite your function like this. And if the x-intercept is the point where the y value is 0, that means that the y value will be 0. And you will solve this equation. Remember your steps for solving an equation. Last step is to divide. And you will have that x is equal to -1, which you can write like this. Now we need to find the y-intercept. So we're going to start with our function again, which we are going to rewrite using the y notation instead of f of x. And now to find the y-intercept, refer back to the instructions. The y-intercept is where the x value is 0, because of course if we want to know the y-intercept, there should be no x, so x is 0. So at this position where the x is, that's where the 0 is going to be. Everything else remains. And we are going to solve this. 3 times 0 is 0, plus 3, y is going to be 3. So the x and y intercepts of this function, x -1, y is 3, match up the x-intercepts of this graph. And it's no coincidence, for those of you that may have noticed, this function, if graphed, will show this line. Next problem. Here they're asking us to state the zeros of the function below, and this function is given in graph form. So if you refer to your notes, it's going to remind you that to find the zeros of the function means to find the x-intercepts. So it's very important for you to remember the x-intercepts and the zeros refer to the same thing. So you go moving along the x-axis. If you can't see that x, this is the x-axis. Move along the axis, and wherever it touches the graph, that's an x-intercept. Here again, keep moving along. Here again, all of those are x-intercepts, so all of those are going to be zeros. So when you write down the zeros of the function, you're going to write this value is -3. It also occurs at 0, and it also occurs here at +3. The final problem, given this function right here, they're asking you in symbol form to evaluate the function when x is -3. So it's important to remember that this notation means wherever there is an x in the function, you are going to substitute a -3. And that is what our instructions on our notes show us in that other example. We're going to follow the same type of information that you have in the notes. So if f of x, given here wherever there's an x, I'm going to substitute a -3. So f of -3 is going to be a -4, and then wherever there's an x, I'm going to put the -3, and then keep on going -6. So we need to evaluate this. To find what the value of f of -3 is, you can always use your calculator and enter this entire expression to figure out its value, which is what I'm going to do. -4, you write it just the same way you have it with the parentheses and everything. Close parentheses, -6. Hit enter, you get the value of 6. So the value of f of -3 is 6. This would be your answer. The next part of the problem asks us, is the point 2, -1 part of this function? Your notes remind you that to do this, you substitute the x and y coordinate values of the point that is given into your function. Wherever the x goes, there's you put your x coordinate. Wherever the y is, you put your y coordinate. So let's try that with our function. Here is our function, and we are going to substitute the value of x wherever the x is, and the value of y wherever the y is. And if you look at your function, you're like, wait, where is the y? So it's a good moment to remind yourself that f of x is the same thing as the y, so that's where you're going to be putting that value. So let's go ahead and substitute. The y is the -1. The rest of the equation, you keep writing it. What x is going to be a 2. And you keep writing. And what you're supposed to check is, do I get the same number on both sides of the equation? Well, on this side, I have the -1. Don't really need to do anything. On the right-hand side, you have an expression that you need to simplify. You may again use your calculator to evaluate that expression. So I'm evaluating the -4 to -6. Notice this is not -6, it's -6. Hit enter. You get a -14. So you're supposed to get the same number on both sides to prove that the point is a part of the function. But in this case, it is not the same. So no, not part of this function. In the last part here, they're asking you, what is the domain of the function f of x is equal to -4x minus 6? It's very easy to see the domain of a function if you can see its graph. Because recalling from the beginning of this video, if you're able to draw a box around your graph, you will know the limits of the axes, and if there's one side that does not have a lid to it, a side to it, then that side extends forever. So we're going to take this function that we have here and enter it in our calculator. Remember that f of x is the same thing as y equals. So this function, you can go to the y equals button of your calculator right here and enter your function, which I have right there, -4x minus 6, and you're going to hit the graph button. It's going to show you what that graph looks like. In this case, it is a line, and we've graphed lines throughout the course before. We know that lines keep going up, down, they extend on both ends forever. So I don't really think that this is something that I can contain inside any box. So the domain would include the entire x-axis, because this graph keeps going up and to the left forever. This keeps going to the right and down forever. So for this graph, I could say that the domain will include all real numbers. So I would write my domain like this. Please work on the practice problems on your worksheet. If you get confused on any part of the problems, you may refer back to this video to remind yourself of all the concepts, and thanks for watching.